Hi everyone, this is Maverick Paul, the Chemistry Guru. Now in this video, we want to discuss the suggested solution for 2020 A-Levels H2 Chemistry Paper 1, question 23. Now question 23, compound T has the molecular formula CxHyOz. It is tested with various reagents and gives the following results. So we have 4 results here. Number 1, when T is treated with a reducing agent, sodium boron hydride, it forms only one organic product. The product has this molecular formula CxHy plus 2 OZ. Result number 2, T can form a compound with molecular formula CxHyOz plus 1 in a single reaction. Result number 3, T gives an orange precipitate with 2,4-dinitrophenol hydrazine. Result number 4, T does not react with sodium metal. So the question is asking which conclusions can be drawn from these results. Option A, T has an aldehyde functional group. B, T has a ketone functional group. C, T has a primary alcohol functional group. And finally, option D, T has both an aldehyde functional group and a ketone functional group. Alright, you notice most of the reactions that we discuss here, it is under carbonyl compounds. So the topic tested in this exercise will be, of course, under carbonyl compounds. Let us run through each of these results, and we want to draw some conclusions. What are some functional groups that are present involving my compound T? Now, result number 1, my T, CxHyOz, reacts with NaBH4, which is a reducing agent, to give me CxHy plus 2 OZ. Now, if I compare the molecular formula, I'm adding 2 hydrogen, so it is a reduction. Reduction, it is the gain of hydrogen or the loss of oxygen. And in this case, most likely, we will know that one double bond, it is present in your compound T, and the functional group present would be most likely a carbonyl compound functional group. Now this C double bond O group can be an aldehyde functional group, it can be a ketone, because both of these carbonyl compounds, aldehydes and ketones, can be reduced using sodium boron hydride. So at least we know that I have a carbonyl compound functional group present, but result number 1 doesn't really tell me whether is this an aldehyde or is this a ketone. Next, let us move on to result number 2. Now result number 2, T will undergo oxidation to give me CxHyOz plus 1. Now effectively what we are doing is we're adding an oxygen, again by comparing the differences in terms of the molecular formula between the reactant and the product. Now actually this idea is interesting. What we can do is we can, based on the differences in terms of the molecular formula, I can deduce, of course, idea number 1, since this is adding oxygen, I know that this is an oxidation, but more importantly, I can try to deduce what is the functional group that is present, because different functional groups that undergo oxidation, the change in the molecular formula is actually not always the same. So let us run this through, and our conclusion is my aldehyde functional group is present, so how do I know this is the case? Now if I consider aldehyde functional group, my C double bond OH, when it undergoes oxidation to give me acidic functional group, carboxylic acid functional group, you notice the difference is I just add 1 oxygen in between my carbon and my hydrogen, and I insert this oxygen between my carbon and my hydrogen, I'll form my carboxylic acid functional group. So it means that oxidation of aldehyde, I'm just adding 1 oxygen, which is consistent with what we have, correct? So most likely T will contain aldehyde functional group. Now how about other functional groups that can also undergo oxidation? What if it is primary alcohol? Now you notice if I consider the oxidation of primary alcohol, when it undergoes oxidation to aldehyde, this is the loss of hydrogen. I lose 2 hydrogen, carbon will lose a hydrogen, oxygen will lose a hydrogen. I form a double bond between my carbon and my oxygen. I form my aldehyde functional group. So losing 2 hydrogen, I know that this is primary alcohol. And if I consider oxidation of primary alcohol all the way to carboxylic acid, you notice the differences in terms of the molecular formula. I'm losing 2 hydrogen and I gain an oxygen. And you notice it is actually quite different in terms of oxidation of primary alcohol to aldehyde and acid group. The change in the number of hydrogen and oxygen is actually not really the same. And if I consider secondary alcohol, when it is oxidized to a ketone, again, we can show that it is the loss of 2 hydrogen. So I think this idea is interesting. We want to keep this in mind. when I compare the molecular formula between my reactant and my product, I can deduce, of course, gain of oxygen or the loss of hydrogen. This is oxidation. But based on the number of oxygen gain and the number of hydrogen lost, I can actually try to deduce what is the functional group that is present in the reactant that can give me this outcome. Of course, other compounds such as ketones, we are not considering that because ketone, as a carbonyl compound, it is resistant to oxidation. It cannot be oxidized. And if I consider alcohol, we are only talking about primary and secondary alcohol. We're not considering tertiary alcohol in this case, again, because tertiary alcohols are resistant to oxidation. So I think this is something interesting that we want to keep in mind. At least based on this deduction, I know that aldehyde functional group is present. Next, how about 3? T will react with 2,4-dinitrophenylhydrazine to give me an orange precipitate. Now this is a distinguishing test for my carbonyl compound. So it tells me that a carbonyl functional group is present. It can be an aldehyde, it can be a ketone. Both of these functional group will give me orange PPT with 2,4-DNPH. Finally, for option 4 or result number 4, T will have no reaction with sodium metal. So if there's no reaction with sodium metal, it will mean that there's no OH functional group present. Alright, so based on our results 1, 2, 3, 4, I know that an aldehyde functional group is present, carbonyl compound is present, which is actually my aldehyde, it is my carbonyl compound, and no alcohol functional group is present. So if I run through my options, A, B, C, D, A, T has an aldehyde functional group, this is true, based on result number 2 that we have. B, T has a ketone functional group. Okay, from result number 1 and number 3, we know that carbonyl functional group is present, but we can't really determine, based on the carbonyl functional group present, whether this is really a ketone or not. So B is actually possible, but if I compare B versus A is clearly a much better answer, correct? Because we know exactly from result number 2, aldehyde functional group must be present. So if I compare A versus B, A is a better answer, even though B is possible, but we have a better answer A. So in this case, we will reject B. Now C, T has a primary alcohol functional group, which is not true, because if I have an alcohol functional group, then I'll have hydrogen gas involved if I'm adding sodium to T. Then finally, D, T has both an aldehyde functional group and a ketone functional group. Again, that is possible. I know that aldehyde functional group is there, but the issue is I don't know whether this ketone functional group is there or not. So if I compare A versus D, again, A will be a much better answer. So if I compare all my 4 options A, B, C, D, I think the best answer to this exercise would be option A. Alright, so that was the discussion involving this question. So if you have learned something useful from this video, please give me the thumbs up, like this video, and subscribe to my YouTube channel for more weekly video lessons. That's all for now. I'll see you next week.